Hey peeps, it's Julian here from Disrupt Tutoring, and as always, it's such a pleasure to join you. We're on to question 3 from the 2017 IEB Maths Lit paper 2, and this question deals with measurement and in particular calculating the area of various shapes, the volume and the circumference. It says Helena and JJ are comparing the size of their pools. Helena's pool is rectangular in shape with the depth increasing uniformly from 0.6 to 1.2 meters, as you can see in this diagram over here. JJ's pool is cylindrical in shape with a diameter of 4.8 meters, and this is what it looks like here. They've also told us how to convert meters cubed into liters, and have given us some useful formulas. So in 3.1, Helena calculates her pool to hold over 30,000 liters of water. If the volume of the water for part/section A, which is this part of the pool, so that's that top part, is 20,160 liters, determine whether Helena is correct. So, this is for 3.1. We need to use two formulas here. So, ultimately we need to use this volume formula. But as you can see within the volume formula, we need to find the area of a base. So first of all, the area of the base is a triangular shape. You can see we're using this part of the pool because they specified that it's so they've given us section A, we now need to find section B. So the formula we're going to then use is the area of a triangle, which they said is, so basically the area of the triangle is equal to half times the base times the height So if we then again, so the height, so the base in this particular instance is this line over here. So it's from this dotted line down to the bottom of the pool. And we can see that to get this value, depth 2 is the entire height of the pool, and depth 1 is the height from the shallow end. So to get depth 2, we can, to get this missing base here of the triangle, we can take depth 2 and minus depth 1. So as I said, to find out the base, it's equal to depth 2 minus depth 1. And they've told us what depth 2 and 1 are. So they say that depth 1 is 0.6 meters, and depth 2 is 1.2 meters. So it's going to be 1.2 meters subtracted by 0.6 meters. And in your calculators, this gives us 0.6 meters. So we've got our base, now we need our height, and we know that our height is actually this line here, because if you look at our triangle, the base is there, our height is up there, but our height is also the length of the pool, which they've given us to be 7 meters. So we can use those two pieces of information now to work out the area of the triangle. So area of the triangle will equal the 0.6 meters, which we calculated over here, multiplied, so obviously don't forget your half over here, so half times your base, which is 0.6 meters, times the height, which I said is 7 meters. Putting this into your calculator, you get that the area of the triangle is 2,1 meters. Okay, so now we've got the area of the base for this within this volume. So we've got the area of the base. Now we need the height, but if you think about it, if we're using this triangle over here, the height, or referred to as the depth, would be this line that spans going that way into the pool. So it's basically this line that's marked as width. So if you think there's a triangle, and then to find, if we imagine going the depth of this triangle, it's going to be that line there. And we know that the width is 4,8 meters. So then we can say, therefore, the volume of the triangle will equal the area of the triangle multiplied by the depth. And we said that the depth is actually equal to the width of the pool, which is 4,8. So we can say this is equal to 2,1. So this is meters squared, by the way, because it's area. So 2,1 meters squared times by the width of 4,8 meters. And this will give us a total of, in your calculators, 10,08 meters cubed. We then need to calculate how much this is in liters. So we can say that in liters, they've given us the formula for that 1 cubic meter is equal to 1,000 liters. So to convert to liters, we need to multiply this by 1,000. So it's 10,08 multiplied by 1,000 will equal 10,080 liters. So then we can calculate the total volume. So total volume will equal the section A, so it's this section A plus section B, which we've just calculated. They told us that section A is 20,160. So as I said, total volume is section A plus section B. So this is going to equal, section A, they said, is 20,160 liters, plus we've just calculated it to be 10,080 liters. So in your calculators, this comes to a total of 30,240 liters. So therefore, she is correct, because the question asked us to state whether Helena is correct, and she said that it could hold over 30,000 liters, and it indeed does hold over 30,000 liters. I'm just going to erase this working out now so that I can have space for 3.2. Okay, some more space to go on to 3.2. So it says, if JJ's pool also holds 30,000 liters of water, then calculate, rounded to 1 decimal place, the depth of his pool. So you can see these dimensions. They've given us the diameter, which is 4.8, but they haven't given us the depth. So we are going to need to use one of these formulas to calculate the volume and hence calculate the depth. So 3.2, because they've given us the diameter in meters, it's best to use the same units of measurements when doing these calculations. So they've given us the 30,000 liters. So if we need to convert this to meters cubed, and remember they've told us that 1 liter or 1,000 liters equals 1 meter cubed. So to get from liters to meters cubed, you need to divide by 1,000. So we'll say the 30,000 liters divided by the 1,000 liters will give us our meters cubed. So this will equal, in your calculators, 30,000 divided by 1,000 is 30 meters cubed. So now that we have it in the same units of meters, we can then use the volume of a cylindrical shape. So it tells us over here that the volume is the area of the base times the height, and the base is a circle. So this is the area of a circle. So for volume of a circle equals the area of a circle times the depth. And now depth is what we're missing. So we know that the volume is 30 meters cubed. So we already got the volume. We can work out what the area is, and then we can solve for the depth, which is what the question's asking us. So let's just find that out, what the area of a circle is, and that's going to equal pi times by the radius squared. And they've told us that, so this formula comes from here, and they've told us that let pi equal 3,14. So this is going to be 3,14 multiplied by the radius. They've only given us a diameter, but remember, diameter is actually 2 times your radius. So half your diameter is your radius. So it's your radius in this case will be 4,8 divided by 2, and this whole thing is squared. So doing some more calculations, we keep it as 3,14 times, so we're going to simplify, so it's going to be 2,4 squared. And putting this into your calculator, you get that this equals 18,0864 meters. So that's the area of the circle. So then, therefore, we know that, so if you go look at this original formula to find the volume of a circle, we've got the volume, which we've calculated to be 30 meters squared. So therefore, 30 meters, sorry, not squared, cubed, equals the area of a circle, which we've just found out, this is meters squared, is 18,086 meters squared, times by the depth. So then if we divide both sides by the area, so if we divide both sides by 18,068, so 30 divided by 18,068, we can then say that the depth is equal to 30 over 18,086, which is equal to 1,6587, and they've asked us to find it out, to round it off to 1 decimal place. So the answer is rounded up because it's 587, which goes up to 1,7 meters. So that is what the depth of JJ's pool would need to be to equal 30,000 liters. Again, I'm just going to erase this to make more space for our next question, 3.3. Oh, so it's erased, and we can go on to question 3.3. They say JJ and Helena both need to replace the tubing that runs around the top edge of their pools. So it would be a tubing going around the top edges and also around there. So they know that they can get a better deal if they buy in bulk. So they combine the length of tubing they each need and then add an extra 10% just to be safe. Show by means of calculation that together they'll need more than 40 meters of tubing. So for this question, they're actually asking us to find the perimeter of the rectangular shaped pool and the circumference of the cylinder shaped pool, and then we add those together, add the 10% just to be safe, and we need to prove that that is more than 40 meters. So as I said, we first need the perimeter of the pool of Helena's rectangular pool. So your perimeter is going to equal 2 times your length plus 2 times your width. Because if you think about it, it's this length plus this length, so it's 2 of them, and then you're going to add that width plus that width, so it's another 2 of those. So this is going to equal 2 times 7. So remember, we get the 7 because our length is 7 meters, plus 2 times 4,8. So these can be grouped together, and that 4,8 comes from the width they're given us there. So in your calculators, this comes to a total of 23,6 meters. Then we need to find the circumference of the pool, and they've told us that the formula for circumference is pi times your diameter. So circumference will equal pi times your diameter, which equals, I said we must use 3.14 as pi, and your diameter, they've told us, is 4,8 meters. So in your calculators, this comes to a total of 15,08 meters. And then we need to add them, so their combined total, so the total length that they need is both their pool edges added together. So it's going to be your 23,6 meters plus your 15,08 meters. So in your calculators, this comes to 38,6 meters. And now we need to add the 10%. So our 10% calculation is, we need to take 38,6 meters and add 10% of it. So it's 10% times 38,6 meters. So, and remember, 10% is also 10 over 100. So we know that this needs to equal 38,6 meters plus your 10%, which is basically 1 over 10 times by 38.6 meters. So if we put that in our calculators, we get that it equals 42.3 meters, which is proving the statement that they asked us. So we needed to show by calculations that they need more than 40 meters, and they do indeed. They need 42.3 meters. If you're a little bit confused about the second last step over here, so remember it's 38.6 plus, so it's a tenth of 38, so it's actually you add 3.86. So this part here actually comes to 3.86. So then 38.6 plus 3.86 equals 42.3 meters. And that concludes question 3.3. Before I go, I just want to give a special thanks to our epic sponsors for making this video possible. Read all about them in our description below. Be sure to visit our website for more of these epic tutorials. If you can't find the answer to your question, remember you can always send us your question and we'll respond with a personalized video just for you. And until next time, stay epic.